And this turned out to be the first practical way of getting energy out of the atoms. For example, I think everybody has heard of Marie Curie,
Yes.
who indeed uh, found, if you like, the second clue, which was that she showed that it wasn't just uranium that emits this radioactivity, but she discovered new elements, polonium that she named after Poland, where she came from, and radium, which is so radioactive that it glows in the dark. So that showed that radioactive was quite a general thing. And then the New Zealand physicist Ernest Rutherford, who moved across to England and then later to Canada, he measured the amount of energy that was coming out of these atoms in radioactivity and realized that it was vast, that radium, there was so much energy trapped inside radium that if you had got just a few grams of radium, there is enough energy trapped inside there that could power a ship across the Atlantic from London all the way to New York. And that is indeed one of the things that was said back in 1910 to show an
Wow.
example of how vast this energy source is. And it's indeed true. It could do that in principle if you're prepared to take 100 years over the trip, because and this was the catch-22 of it all, if you like. In a way, it's sort of obvious that if these atoms have been dripping this energy out for 4.5 billion years, they must be doing it very, very slowly. And indeed, that was the case. So they tantalizingly discovered this vast source of energy, but it was coming out so slowly you couldn't do anything very obvious with it. And this turned out to be the first practical way of getting energy out of the atoms. And it was also the first thing of application, because that is key to today. Anybody who's had a PET scan, positron emission tomography, as I did in my treatment, for example, or radiology and so forth,
Yeah.
has benefited from the fact that you can induce radioactivity in normal matter and then make use of it in medicine and in diagnostics in particular.